Today we are going to see about coordinate geometry. It is a basically maths with visualization. So we are going to see two things, more than two things. So what does a coordinate plane look like? Structure of coordinate plane. So this is the coordinate plane, and in here we have markings, which can be 1, 2, 3, 4, 5, 6, 7, and so on. This arrow represents that the line will go all the way till infinity. Same here, it will be -1, -2, -3, -4, -5, and -6. This will show, so these are all in negative numbers. So this is known as the x-axis. So x-axis is in horizontal. And now the next is going to be y-axis. Next is y-axis. Y-axis is along the vertical line of the graph. So it can go like this: 1, 2, 3, 4, 5, 6, 7, and so on. And same here: -1, -2, -3, -4, -5, and -6. These all should be the same length. So now we will see how to represent a point in the coordinate plane. So when we write a point, we write in the format of x, y. First we tell the x-axis and then the y-axis. So for example, if we have a point 3, 2. So first we will move 3 units along the x-axis, 1, 2, 3, and then we are going to move up 2 units. Since y-axis is the vertical line, so we should go up 2 units. 1, 2. So here will be our 0.32, and we can even represent this like this. But we can also have negative numbers in the coordinate plane. So for example, it can be also -1, 2. So -1 means -1 along the x-axis, since the format is xy. So -1, and then we go up 2, 1, 2. So this is going to be our point, -1, 2. So now next we will see about quadrants in the coordinate plane. So now we will see about quadrants. Quadrants So there are 4 quadrants: first, second, third, and fourth. So we are going to see all of these. So let me just mark these. So the first coordinate starts from here, and then we start to go anti-clockwise. If we go anti-clockwise, so this will be first quadrant, then second quadrant, and then third quadrant, and then after this it's going to be fourth quadrant. So now we will see what is the pattern of the coordinates in these quadrants. So in the first quadrant, both are positive, so plus plus. And then moving on to the second quadrant, we can see that the x is negative, so negative, and the x-axis is positive, so this will be positive. And in the third quadrant, we can see both of these are negative, so it's going to be negative, negative. And in the fourth quadrant, we can see that x is positive, and y is negative. Now we are going to see distance formula. So in distance formula, we find distance between 2 points. So first we are going to see it graphically, and then we can also do it without any graph and using only the coordinates that we are given. So let us see this first graphically. So let me just put my points. So this is 1 2 3 4 and 1 2 3 and 4 and 1 2 3 4 minus 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 minus. So the distance between this, let's suppose that the first coordinate is 1 1, and the second should be 3 2. This point, second is 3 2. So we need to find the distance between the two. So we can use Pythagoras theorem, which says that a square plus b square is equal to c square, and we can clearly see that. So we can see a right angle triangle is formed if we join these 2 points, and we get a right angle triangle. So we can see, first we need to find the length along the x. So in the x we can clearly see that this is 2, or the other way to do it, subtract the final one to the initial. So this can be also written as 3 minus 1, 2 units, and this is going to be 2 units. And along the y-axis we can see the initial is 2 and the final is 2 and the initial is 1, so we can simply subtract it to get 1 unit, and we can say that this is 1 unit. Now we know that this is a, b and c. So we know a, b, so we can now find c. So what is a? A is 2, so 2 square plus b 1 square is equal to c square. Now let's expand the brackets. It's going to be 4 plus 1 is equal to c square. Simplifying this further, 5 is equal to c square, which means that c is going to be equal to root 5. So our this length is going to be root 5. So now we can solve this graphically. Now we are going to see it how we can do it just using the two coordinates. Now we are going to use the distance formula, where we can find the distance between 2 points using only x1 y1 and x2 y2. So I did not make any markings, but we will be provided with the coordinates. So our first point, it is going to be 1 1, and our second point, it is going to be, let's say, 10 9. So we can find the distance between two just by using the distance formula. So the distance formula states that the distance between these two is equal to x2 minus x1 squared plus y2 minus y1 square. So now we can see how it is true. So first we need to find the difference in x. What is this length? We can form a right triangle using these 2 points. So we're going to subtract the final from the initial to get this point. So the final is 10, and we're going to subtract it with 1 to get 9 units. So this is again going to be 9 units, and then we need to find the difference along the y-axis. Along the y-axis it is going to be 9 minus 1. This is 8 units. So in these steps we found the lengths of the triangle A and B. So using A and B, so again this formula came from the Pythagoras theorem. So using Pythagoras theorem, we just found a is going to is equal to x2 minus x1 and b equal to y2 minus y1. So now we can find c. So now we can see that it is the formula states that it is a square plus b square is equal to c square. So the same thing is going on here. This is a square and this is b square. And if I were to square root both of these sides, square root of this side and square root of this side, we would get c is equal to square root of a square plus b square, and we can clearly see that here. So now moving on to finding the distance between these two. Now we can directly plug in our formula. So what is x2? x2 is 10. So we're going to put 10 and then x1, which is 1. x2 is 1 plus square plus 9 minus 1 y2 minus y1. So what are we going to get? 9 square plus 8 square. Further simplifying, we get we get 81 plus 64. So we can add it. 81 is 64. 81 plus 64, 4 plus 1 5, and 8 plus 6 14. So 145. So our answer is going to be square root of 145. So the distance between these 2 points is going to be 145 units. Now we are going to do another example. Now we are given 2 points, 3 1, and our second point is going to be, first one is 3 1 and the second one is going to be 9 9, and our second one is going to be 9 9. So now we can directly use our distance formula. So we can see x2 minus x1, 9 minus 3 squared plus y2 minus y1, 9 minus 1 squared. Now we can simplify this to get 9 minus 3 is going to be 6. So we are going to do square of 6 plus 8 square. 9 minus 1, 8. Further simplifying, we get 36 plus 64, which is equal to root 100. And we know that root 100 is equal to 10. So the distance between these 2 points is going to be 10 units. And by using this distance formula, we can find the distance between any points. Now we're going to do another formula which would include negative coordinates as well. So now let us imagine that we have one point minus 1 minus 1 minus 1, and other is going to be 5 7, and other be 5 7. So again we can simply plug in our distance formula. This time 5 minus x2 minus x1, so 5 minus minus 1 squared plus 7 minus minus 1 squared is equal to, now minus minus means plus, so this is going to be 5 plus 1 squared plus minus minus plus 7 plus 1 squared. So this is going to be equal to 6 squared plus 8 squared, which means 36 plus 64, which is root 64, root 100, and we can say that this is 10 units away. Now the reason that this gets add over here, because first we will count the distance from this 5 units, and then we are going to find the distance from this. Also, this is also included. We don't subtract it, since we are doing distance formula, and in distance everything adds up. So this total, that is why the total is going to be 6 units, and we can clearly see that also by the distance formula, 5 minus 1, which simplifies to 5 minus 1, and with that we can now, the basics of coordinate geometry is over. Thank you.